Greetings everyone, I'm TJB Chris and this is my TRS-80 Model 16B. And today we're going to be doing a little pre-upgrade build. This machine currently has 512K of 68,000 memory. So we're going to be upgrading or building the upgrade to upgrade this to 8 megabytes. And that's going to involve the assembly of two boards. One is an 8 megabyte SRAM based board designed by a group of former Tandy engineers, now community members as well, calling themselves Tandy Emeritus. The other portion that's necessary is an MMU upgrade to allow the machine to access all 8 megabytes in userland. This upgrade was available, the MMU, and some other memory upgrades were available in the 1980s, late 80s. One MMU designed by Tandy that allowed access to 4 megabytes of memory. But this is an additional MMU, a 3-bit MMU extension to allow the machine to address all 8 megs. Without any MMU upgrade, the machine can address 1 megabyte as userland and the remaining space as swap. So this will allow me to have, well, actually 7.5 megabytes. There's a 512K of RAM reserved for various bits. It's actually going to be 7.5 megs of usable space, but that's still way more than 512K. So in this video, we're going to build the new boards I got, and then we're going to pop the CPU cards out of the machine and the memory cards for the 68,000 subsystem, take a quick look at those, go over what's next, and move on. If this video seems a little oddly worked out, that's because originally it was going to be a one and done, but then I realized that it was taking too much time. I was stockpiling footage, and I just wasn't going to get it all done in an amount of time that you guys were all going to want to watch. Let's see it get built. This is going to be mostly time-lapse unless I say or do anything funny or stupid. As you can see, the area is a little different here. Next to the Model 12, I've taken away the other Model 4. I put one of the Model 4s away, have the other one out, and gave myself a nice permanent work area again. I've missed it, and I've also been organizing, so I now have lots of components I've been spreading around the room over the time have finally caught up to me, and I finally got to organizing it. All right, apologies in advance, static shot as usual, and let's do this. All right, first little bit, there's two pieces to this again. There's the actual SRAM board. It's an 8 meg board, 7.5 megs will be usable. And we have the MMU extension. I just hit my elbow on the desk there. So we're going to focus on the memory board first, and the general order we're going to be looking at this, I think, is going to be this first, because nothing else is there. It'll be easier, the SRAM. And then we'll kind of start moving on to sockets and caps and the regulator and all that other good stuff. So let's go. Very important. Flux, flux, flux. You need good flux. This is new flux. I actually have no clean flux paste. Hopefully it works fairly well. I think we're okay. I think we got it. Look at that. Okay, I think we did it. Let's just clean up the flux a bit. Yay! I think we got it. All right. All right, next item up for bids. All right, next up, let's start doing some sockets and headers. So let's see. I think I want painter's tape. All right, I always like to use painter's tape to hold components on. So that's what we're going to do. And let's look for pin headers and sockets. Okay. And let's see here. Let's do pin headers first. Let's do pin headers. Almost forgot to take the smoke detector down. Oops. Oh, got it before it scared the crap right out of me. Because it would have. It would have scared the living shit right out of me if I had done that. There we go. We have a header. A little gapped, but I didn't have the full-on one-piecer, so we had to improvise a bit. This should do nicely. Let's see, we have other pin header requirement possibilities. I don't know that I need these to start, so I think I'm going to pass on them. I do need the individual tips, and I have those floating around. All right, well, it's come to my attention that I did not get my 24-pin thingamahoosers yet. So, this is where we end it, and I'm just going to have to go order those. But for now, we're kind of stuck. So, we're just going to have to stop here and come back. All right, we're back. Slightly different angle, slightly different color temperature on the light, and different lighting. I have ceiling lights now. I put in system last week. So, got my sockets. Let us get the sockets in, and then we're going to do caps. And yeah, back to music and high speed. I'm going to start with the bypass caps. There are, what, 8 of them? 2, 4, 6, 8 of them. These are tantalums over here, and this is an electrolytic one. So let's start with the bypass caps, because I can get all of those in. Let's do the regulator first. I feel like that's going to be easier. Let's do the regulator. Okay, now tantalums. So there we are. I think we're all soldered for the parts I'm going to do. There's some headers for optional stuff, but oh no, resistor networks. Resistor networks. Okay, let's do those. There we are. I mean, the LEDs are optional, but if it's going to light up, it's got to light up. I mean, why do it? Okay, let's clean this up. Since we're going to move on to some chip testing, I'm going to put this away, just organize myself a little bit, and then we'll change the angle a bit and break out the retro chip tester, and I'm going to test every chip before I put it in, because this way there's no worry. All right, so I've got, these are 7.4 LS240s. I believe I need 3. And we're going to test them first because usually for parts like this, especially for mouse or whatever, I usually come out okay, but it'll save me a lot of troubleshooting later if I test these now. So let's just get these in. Alright, it just occurred to me that I'm still missing a piece that's out for back order, 7.4 HCT 540. Don't have that in yet, so that's where we're going to pause until that comes in. Alright, another day, and we're back again. Turns out I realized I'm missing 7.4 HCT 540. I guess I missed it when I was ordering parts or something. So what we're going to do today is we're going to stuff all of the non-programmable logic that I have. So I'm not going to do the gals yet because I want to program them all at once. But I am going to stuff, I have the rest of these 74 series chips. There's a couple of 3 240s, 2 640s, a 138, and a 7407. So we're going to stuff those, and then we'll move on to, I think we're going to start doing some of the sockets on the SRAM board. There we are. So we just have the gal. So let's warm up the iron and let's get ready to stuff some parts on the SRAM board. Put this aside. Alright, and this has got a trick to it because you essentially have 2 overlapping sockets here. One that's you're gonna pull the 68,000 CPU out of the CPU board and you're gonna plug this into it in its place. So you gotta solder these both in the right order. And also you've got to get them in the right place. So there's these pin headers where the longer pins are actually thinner than the shorter pins here. Shorter pins go into the PCB, longer pins will go into the 68,000 socket. So what I have to do is line these up so that I have these correct. If I can get my shaky hands to work today. There we go. And now we have very nice. Now, I don't have a breadboard to put these in. The instructions suggest using a long breadboard to put these in, but I don't have one free that I can use. But they do kind of sit flat, so I'm hoping that means I can, if I get this flat, I should be in pretty good shape to be able to put these in. Let's see what it looks like underneath. I think that's going to work. Alright, so I think we're good to solder. We're in the right rows because the CPU socket goes on top. And you have to do these first because otherwise if you do the other one first you won't be able to access these pins to solder them in place. So here's what I'm going to do. I'm going to touch just a couple. And how are we looking? Actually, I'm pretty happy with that. Look at that. Okay, that's good. The pins are well aligned, straight, long ones down. Let's go. Okay, next little item. The instructions recommend putting on a socket. And this, because these pins are so fragile, this way I don't run the risk of breaking them. I can put the socket in. If I F up the socket, I can just pop it off and pop a new one on there. So I've attached these, again without a breadboard, so what I did was I kind of put it on lightly and then went down through, putting a little even pressure on it straight down on both sides. And that seems to have gotten me lined up. So now we have protected pins. Yay! So we've got a bunch of 20s, so let's focus on 24s. These. There we go. MMU board built. I'm going to stuff the logic that's not programmable, which there's really only 4 bits. 5? 5. The gals I'm not going to do tonight. I'm going to program those another day, but that's it. I'm pretty happy with how this came out. I had to cheat a little bit on one of the sockets here. This is supposed to be a 20 pin, but I didn't have any. I had all the dual wipe ones, which aren't wide enough to take the cap in here, the bypass cap. So I trimmed down one of the 24s, and I was able to do that successfully, so I used that instead. Might cause some frowns, but it will work just fine, and actually I thought I did it fairly elegantly, so as elegantly as a hack like that can be. But anyway, we got our bypass caps, we've got our axial electrolytic, we've got our 4.7K resistors. Yeah, all right, let's stuff some parts. All right, and this is the finished product. We have our 2 boards. I have my SRAM board. I have not populated the gals yet. We have to program those. So that's going to be next, and then we'll populate those. There's a gal here that needs to be programmed. So we have those parts. Overall, I'm pretty happy with it. I don't think I can get the camera to focus on the SRAM, but I'm pretty happy with it. That takes some practice on it. I don't think I have any solder bridges. I went over it with a fine-tooth comb and didn't have too much trouble. I did have one little spot of solder that kind of bled across them, but I was able to wick some of it up, and then I had a little bit that I was able to scrape away with a small pick and then clean up the solder. So that seemed to go well. The voltage regulator isn't exactly straight, but it is on all the pads and lined up and making a connection, so I'm just going to have to tell my OCD to take a hike. So yeah, let's move on to the gals. I've got gals, 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 and pals, pals, pals. So I guess that means I've got gal pals. Aren't I hilarious, folks? Okay, on to the gals. And there we are. That's the SRAM board. Now, when this goes in the machine, this jumper is going to connect. This is TP1, it says here, TP1 must be connected to pin 33 of the 68,000 CPU card J2 connector. So we're going to have that, and there's another piece to this. So let's do this. We're going to pull the 68,000 CPU card and the memory cards out of the back of the machine, and then we're going to look at the modification we have to do and program that PAL. Actually, let's program that PAL first, and then we'll do that. So back to this. All right, let's get into the back of the 16B here. On the way out, you're going to notice I made a little modification to the turbofan mod. I think I mentioned once in a previous video this fan's replaced. I'll put another 120V fan in there. And so we're just going to remove this, and here's my little mod. Normally the turbofan cable is a straight direct connection to the distribution back by the power supply, and that's a pain in the ass. So when I replaced the fan, I took the opportunity, if I can get this off with one hand, I cannot. So I took the opportunity to replace it with an inline connector so I can remove it and disconnect it entirely. So makes that much easier. Set this aside. All right, our 68K cards are up here, the 2 memory boards and the CPU cards. So I'm going to pull this off of each and remove these cards. And then we'll take a look at the CPU card. And there we are. There's our CPU card. Let's take a closer look. All right, here are our cards. I have the 2 memory boards, each with 256K of memory, so this had 512K. So an 8 meg jump, 16 times more RAM, this is going to be great. And then we have the CPU card. And the CPU card does not have any of the upgrades necessary to run Xenix 3.0 unpatched. And I know what you're thinking. You're thinking, I've seen this machine running Xenix 3. How does that work? And that's because it was patched to remove the requirement for the PAL upgrade for burst mode. So instead of trying to leave it that way, we're actually going to do the burst mode upgrade on this and a couple of other modifications that kind of come with it. So there's a PAL upgrade, there's a modification, 2 PAL upgrades, the BERR burr modification, I guess, and there's a weight modification. So each of those has to be done, and actually, given the length of this video, I think that's a good time to stop this. So now that the new SRAM card and the new MMU card are assembled, these cards are out, I'm going to get together the components for doing the upgrades on this, and then we'll perform the upgrade, put it in and test it with the original memory cards to make sure everything's functional with a non-patched version of Xenix 3, and then we'll get to testing the other boards, which coincidentally are right here. And I didn't have the handles on last time, so now we have handles. So those handles came with the board. They're very cool. So anyway, until next time, thanks for watching, and stay classy.